Okay, welcome back to Math 2. We're going to do 46, 47, and 48 on this one. The circle as a right is inscribed, which means it's just inside the regular hexagon. What's the area of the shaded region? So if you look at the picture, you've got the hexagon on the outside, the circle's on the inside, and the shaded region is that little part in between the two. So ideally, what we do is, I'm going to set you up, so maybe you can just kind of do this by yourself. You find the area of the hexagon, the old-fashioned way that we used to do. Find the area of the hexagon. Take out the area of the circle, and then you should be left with the area of the shaded part. So that's where we're actually going with this problem. So area of the hexagon, take out the area of the circle, and then what you're left with is the area of the shaded region. Okay, so area of the hexagon is just like any other hexagon that you used to do before. Forget the circle part. What you're really concerned about is finding the area of that. So if you have your learning log, you should, on how to find the area of a hexagon. It's got six of them, right? So that means if I take, let's say, this triangle inside here, and this is a 6, you need to find the angle on the inside like we used to do. So 1, 2, 3, 4, 5, 6. So 6 minus 2 is 4 times 180 is going to give you, so 4 times 180 is going to give you 720. So what is this? 6 minus 2 times 180 is going to give you 720. 720 divided by 6, because technically divided by 6 is going to give you 120. So 120 cut in half is 60. Okay, so this is a 60 degrees. And then we need to find the area of the triangle. Oh, this should be pretty easy, because now we know for a fact that it's a 60, 60, 60. So this is 6 and this is 6. So that's 6 and that's 6. Okay, that takes care of that. And then you need the height. Okay, so let's say this is x. So this has got to be 3. This has to be 3 because it's cut in half. So there's your triangle. 3, 6, x. Oh, this is perfect. So 3 squared plus x squared is going to give you 6 squared. So x squared, 36. So x squared is equal to, I don't know, what was 36 minus 9? 27, and then the square root of 27 is somewhere around 5 point, what is it? I don't know, let's just say 5.2. That'll take care of that. Okay, so now the area of your green triangle should be base times height divided by 2. So 5.2 is your height times your base, which is 6. Oh man. 27 square root is this times base, and then divided by 2. So it's 15 point, I don't know, 588. So 589. No, 588. 588 is good. And then multiply that by 6. So area of your hexagon should be, what does this thing say? 93 point something something. 0.53. Okay. All right, so that's the area of a hexagon. Area of your circle, well, you just have a circle. There's a circle. You have your radius is 6, so area of your circle is just pi r squared. So that's 36 pi. 36 times pi. 6 times pi equals around 113.097-ish. Yeah, okay. So area of your circle is around 113.097. Wait, that doesn't make any sense. That one's bigger than the other one. Okay, so something went wrong. You can't have the circle be a bigger area. Yes, you can, but the thing still has to be bigger. Okay, now I'm really confused. Okay, now I gotta go back and check this work. 5.2. I know the circles usually has a bigger area, but this thing doesn't. This thing doesn't make... Subtract the area of the circle from the area of the hexagon. Yeah, so we should get a positive number. We can't have a hexagon smaller area than the circle, because then you're going to end up with a negative. Okay, something went wrong. So what did I do wrong? That's 3. 36 minus 9. That's 27. Take the square root of that. That's 5.2. Okay. So that's the height. Height is this. Base is 6, so height base times height divided by 2. That's the area of one triangle times 6, because I've got 6 of them, is 93.53. Okay, so now I have no idea. Something's wrong with this picture. Subtract the area of the circle from the area of the hexagon. Yep. Okay. Well, that definitely should not make any sense. I definitely still got 93.53. What did I do wrong? Alright, I'll come back to this. I'll figure it out later. Because otherwise, I don't know what to tell you. So, 113.097. But that doesn't make any sense. The hexagon has to have a bigger area than the circle to subtract from it, because otherwise you get a negative answer. So, somebody who's watching this, please tell me where I went wrong, because I'm too tired right now to try to figure it out. Okay, 47. Use what you know about similar figures to complete the following tasks. What's the area and perimeter of the trapezoid at the right? So basically what they said is do not assume that's isosceles even though it looks like it. Start by solving for x, so this part down here at the bottom in the diagram, then solve for y, which is this part right there, and then go here. So I guess we could call this part z. And then see what it is. So x should be pretty easy to find because it's a 4, 5. So this is technically a 3, 4, 5 triangle. This is a right triangle. So x is definitely going to be 3. So that's your Pythagorean triple, 3, 4, 5. And then if you're not sure, do 4 squared plus x squared equals to 5 squared, and then you should get x squared equals 9, and then square that is 3. So that's 8 and 3. So 8 plus 3 do not make 13, which means we should have a little bit left over. 8 plus 3 is 11. So, ooh, that's nice, because then we should have 2 actually left over. 11 plus 2 is actually 13. So 3 plus 2 is 5. I'm sorry, 3 plus 2 is 5, and then plus 8 is going to give you your 13. So that's 2. So here we actually have a 2, 4, and we need to get z. Oh, that's not very helpful because now it looks like the z's and the 2's are the same. So you have 2 squared plus 4 squared is equal to z squared. So 4 plus 16 is going to give you your z squared. So 20 is equal to z squared. And then the square root of 20 is... Wait, clear. 20 square root. So z should be somewhere around 4.47. So let's say approximately 4.47. Okay, now the area is, for your trapezoid was, you're going to have to calculate this. So your area for the trapezoid, if you don't remember the formula off the top of your head, was base 1 plus base 2 times the height divided by 2. And then your perimeters just add up all the sides. Now, on part B, it says, what's the area and perimeter of a trapezoid that is similar to this one, but it's reduced by a scale factor of 1/3. So basically, once you find your area and your perimeter, just multiply it by 1/3, and you should be able to tell me that the area and the perimeter of the smaller one is 1/3 of this one, the bigger one. Dang it, I'm still upset about this. I don't know why. It still bugs me. Okay, 48. Mr. Singer has a dining room table in the shape of a regular hexagon, because obviously Mr. Singer is a math teacher and he's just in love with stuff that are polygonal in shape. And while he loves his design, he has trouble finding tablecloths. No joke. To cover it, so he has decided to make his own. Oh, and he sews. In order for his tablecloth to drape over each edge, he will add a rectangular piece along each side of the rectangular hexagon shown at the diagram on the right, using the dimensions given in the diagram. What's the total area of fabric that he's going to need? You do not need to consider the area needed for the seams. Okay, so we basically just have to find the area of the hexagon inside, and then multiply or add it to a bunch of rectangle areas over here. Okay, so the diagonal is this one. It looks like it's a 6. So that means if you redraw your hexagon, you should get a, it's in the middle, so half of it is going to be 3. And this length is 1, but we don't, that's not what we need right now. Oh, they did it for us down here. Oh, that's nice. So we basically need to literally find the height, and we need the base too. So I guess we need to find y over here first and then double it up. So they actually did it for us on this bottom part right here, which is nice. There's the 3. They did the hexagon, so this is 30, 60 for you already. This is y. Actually, I'm going to change this. Let's call this x, and let's call this part y over here. So if you were looking for x, it's across from the 60 and the hypotenuse. So sine of 60 degrees is going to be your x over 3. And then cosine of 60 degrees is going to give you your y over 3. So that gives us a value of x and a value of y at, I need the other calculator. I don't want to do that. Sine of 60, square root of 3 over 2. Times 3 should give you a pretty interesting answer. Sine of 60 times 3. 2.598. Is this 2.598? And cosine 60 is, oh, it's half, duh. Times 3 is 1.5. Okay. Oh, yeah. Well, that should make sense since this is technically an equilateral triangle. I don't know why I didn't think of that. So this is 1.5 because it's technically half of 3. This length is 3. And then this is 2.598. So 2.598. So your area of your hexagon is, let's see, base is 3. 1.5 and 1.5, so the entire base is 3. So 3 times 2.598, base times height, divided by 2, times 6. So it should be 23.382. That's the area of the hexagon piece. And then each of these rectangular pieces, it's 1 inch on top with a base of 3. So the area of the rectangle, or one rectangle I should say, so the area of one rectangle is 1 times 3, so it's 3. And you have 6 of the rectangle pieces, so times 6. So you have 18, what is this, inches? 18 square foot area for the rectangle pieces, plus the area of the hexagon piece. So 18 plus 23.382 is around 41.382 feet squared worth of area. Sorry, I went really fast and it's kind of hard to see now. So area of the hexagon, you should get 23.82, doing it on your own. Area of one rectangular piece is a 1 by 3 because it's 1 tall, right? And it's 3 wide because it makes up the base of the triangle. So 1 by 3 is just 3. You have 6 of these guys because the original picture had 1, 2, 3, 4, 5, 6. That's 18 feet squared for the rectangular pieces, plus 23 feet squared for this piece. Add them together, you get 41.382 feet squared of tablecloth. Okay, and wow, just those 3 actually took 15 minutes. I'm still trying to figure out why this went wrong, because there's no way. Man. Oh my goodness, I bet you I just did this. Oh, I know exactly what went wrong. Okay, the radius is not 6. That's where I thought I went wrong. Wow, that was horrible. The radius is actually the height, because it stops right here. The 6 actually keeps on going past the circle, so it's not really the radius. Dang it. Okay, so the radius is actually the height. The height was 5.2. Okay, that makes so much more sense. So area of the circle is really pi times 5.2 squared. I'm so glad I figured that out. So 5.2 squared is 27.04 times pi. Yes, area of the circle is 84.95. Let's just round it up to 84.95. So area of the circle is 84.95. Area of the hexagon is 93.53. Take away from 93.53. What do we have? So the area of the shaded region is 8.58 inches squared. Okay. Woo! Glad I figured that one out. That would have been embarrassing. Okay. See you guys later.